Really happy to have Dr. Brian McConkey with us. So Brian is the Chief Science Officer at Viresco Solutions. So, part of coming out of this project, you know, alluded to earlier, originally we were hoping to get into a practice-based type protocol, which may have been supporting some of Doug's comments just now about incentivizing and innovative management practices being put out on the landscape. And we know inherently, even from our BMP guide work that we did, those practices are going to bring more carbon to the table. The challenge we have is backing and backstopping that with good science and moving that down the lane. And I guess the way I describe it is that the data set that we found was coarse and didn't allow us to drill down into kind of practice-based type incentive work. So over the last kind of year, Brian will take us through the timelines, but we've developed this soil carbon roadmap that we think will help us to focus our work over the coming years and maybe leverage some of the partnership opportunities that folks like Ian and his team are bringing to the table, and the good work that the Forage Councils are doing across the country in their projects, and start to build up that data set so that we can maybe start to answer some of those questions, good questions that Doug is asking us here today. So, Brian, over to you, my friend.
Thanks, Cedric, and thanks to CFGA for this opportunity to speak. So, hopefully you can see a presentation.
We're seeing that. Yep.
Okay, so just as Cedric says, this is sort of another step towards this challenge of getting offsets into the grassland that are relevant to grassland, and this has been quantifying the change in carbon for existing grasslands due to improved management. So a lot of this is a review. I think Karen went over a lot of this this morning, but I think it's still important that we got to remember there's a difference between carbon stocks and carbon stock change, and particularly in this area where we're trying to look at how management will change carbon, we're really talking about carbon stock change. So we may have lots of carbon in the soil, but we really only need to know that very small amount that's changing, and that's very small, like maybe 1% of total carbon per year. So that puts a real challenge on how we quantify that change and build an offset around that change. So we've already, there's been a lot of talk about the avoided conservation protocol, and of course that's in some ways a little bit easier because we're really talking in this case about preventing the loss of a large amount of stocks. And but the next challenge is, and how do we do the stock changes on existing grassland to improve management? So the first thing we looked at, of course, was measurement-based protocol. So there you really need measurements of the soil. One way is through measurements, and obviously soil organic. You need to measure the soil organic carbon stock over time. And then, obviously with measurements, you're not really need to know exactly how it's being managed because you're really just looking at the outcome. So you just say, okay, whatever's happening, we can measure an increase, that's good. And then reward offsets based on the actual measurements. But at this point in time, it's really not feasible. The costs are just too costs that really be prohibitive. There's very little money left for the land, the grassland manager. New techniques like remote sensing and that certainly can contribute valuable data, but they're really just not there yet. And then linking the measurements, using the measurements more strategically with biogeochemical models or computer models would be one way to reduce the sampling requirements. So we said we sort of ruled out the measurement-based protocol. So then the next one was sort of practice-based. It's something we're more familiar with. We've seen this in a lot of protocols, such as the Alberta Conservation Cropping Protocol, is all based on just practice. So again, you define the practices, then you estimate what would be the carbon change for those practices. But really, when we look at it, it's just not feasible yet. There's just every farmer or rancher is different. So you might say what's, adaptive multi-practice grazing could be a practice, but what that means and what is the adaptive part of it is going to change for each and every rancher, depending on their particular circumstances. Even if they're, even if they're neighbors, it could be very, very much. So it's really hard to define what is a practice. Certainly, trying to come up with what is, the practices and particularly what would be the carbon changes for that. There's just not enough good science yet behind that to be able to do that with any consensus. And then, the other danger is, of course, you're starting to say, okay, if you can manage just exactly like this, then that's, we can give you this credit. But if you deviate from that, that's then you won't get the credit. And of course, that is exactly in some ways what we don't want to do. We want to make sure that the grasslands are well managed because of the challenges with weather and the way markets move or whatever. We want to be able to to make this sustainable. We need the grassland managers have to be able to have flexibility to adjust the management to their circumstances. So again, we have to rule this out. So that really then brought us to what would be this. How could we do this? So that's what we call the soil organic carbon roadmap. So we also had some research funding from Alberta Innovates, in addition to the CFGA support. So so really we were assessing here, how do we be able to quantify this organic carbon change for the grasslands, for the grassland management? And this gap is, so we identified it, but it's not just us have identified it. This has been a problem for quite a while of quantifying carbon change on our grasslands, and also include forage lands. Even shorter term forage lands are also kind of a science gap for us. And again, what we need is something that has enough rigor and enough practicality that we can actually build this into an offset system that would enable environmental markets to support improved grassland management, and also by making grasslands more profitable from the additional revenue stream. Also, it'll also have the effect of hopefully preserving some grasslands as well, or assisting with other market-based mechanisms to preserve grasslands. So this enable development of an offset system that would be based on the practices that were the actual practices that were being done on a particular ranch or farm. So one of the reasons why land is in grasslands is often because the underlying landscape is very variable and heterogeneous. It's often rough lands, may have had erosion in the past. We have different types of vegetation. So all this makes it again, it's very difficult to ever quantify through sampling. So just doing kind of an exploratory sampling is not going to really provide the really hard data that we need to address our science gaps. And of course, the land management practice varies significantly between farms. So we need to make sure that we at least we can really look at sort of the practice in the context of the exact environmental soil situation of the farm, and be able to capture that with enough rigor. So there's really a need for sort of high quality measurements of very complex and variable landscapes. So it definitely requires time to measure changes. The bigger the change is, the easier it is to detect, and the longer you have it, then the bigger the change you expect. So, you really can't, in most cases, ever hope to sort of measure changes in 1 year, 2 years even. So you really need to, need to be looking forward and making sure you measure changes over several years. Again, remote sensing, as I said, certainly has some certainly has some opportunities, I think, to support other methodologies, both modeling as well as even helping you determine where to sample more efficiently. But at this point, anyways, isn't certainly sufficient there to, in a sense, quantify the carbon only from remote sensing. And so we really need these good quality data sets linked to the land management information. But they're expensive to generate. And right now, they're not really compiled. So even though we have lots of activities and have had lots of activities over time, a lot of that is, in some cases, lost. It may be sitting in reports, but all the data may not be in the report, but still may be sitting in the file cabinet. There's just a lot of cases where we to leverage what we've already invested in, and also to make sure that new investments into carbon measurements are given maximum value. So we need to really be able to compile all these data sets into something that is accessible, that will enhance our scientific understanding with again, the goal of being able to quantify the carbon change for offset systems. So really then the roadmap, where we go to, obviously we looked at all the sort of work that's going on globally. What would be the best approach? How to, again, efficiency here is so it's critical. Then engage with a number of significant stakeholders, discuss the current state, various gaps, and possible solutions. So we involve academia, research institutions, governments, technology providers, industry associations, consultants, and other technical experts. And then, so we had this working group. Then we had 3 different meetings there, and then we had one final workshop where we had a much broader range of stakeholders to make sure that we weren't just coming up with something that kind of was sort of nerdy and scientific, but something that resonated with a broader group of stakeholders. And then we started also immediately collecting the list of what's already out there going in terms of monitoring soil organic carbon change, so we can start to immediately see sort of the opportunity that we already have existing to forward this soil organic carbon roadmap. So the approach that we took was really one where it was essentially we make the estimates with modeling, but those models had to be underpinned by strong monitoring support of soil organic carbon. In other words, it's the actual observations on the ground that really determine whether the model is valid. And what the modeling does is it allows us to have that tremendous flexibility. So different weather, different vegetation types, different ways of managing on each individual farm can be put as input. And so we can capture that sort of farm-specific or ranch-specific carbon change and be very efficient then, because we can underpin this whole model and validate this whole model with strategic monitoring support. So we don't have to, we hopefully, the idea is to have your cake and eat it too, essentially be able to be more or less outcome based on the farm level, but be very efficient in terms of cost effective anyways, in terms of using what your measurement resources for, so like on carbon change, so that they strategically support that modeling effort. So, we need these measurements to support calibration, and particularly validation. So calibration just means adjusting the model so that it fits the observations better. But the really important question is, if we try it on sort of a new sort of situation that we didn't adjust for, how well does it work? And so we really need that continual validation. We need these high quality data sets to cover the range of practices, land types, and weather for which we're applying it. But fortunately, one of the big advantages of this thing is we don't necessarily have to pick what's called representative combinations. We're not using these measurements to derive the actual coefficient, if you like, of soil organic carbon change, but really just to provide that support for the model. So that actually frees us up. It actually makes the task a lot easier, because in some cases we don't know enough even of what's going on in the land to know what is quote unquote representative. But certainly we do know enough, I think, to say, well, this is the sort of range of things that are happening out there. As long as we can cover that, then that would be sufficient to support the model. We also just want to make sure that, in addition to something that's already done in the past, we want to have some ongoing measurements to make sure that the model remains validated. Climate change is occurring. We may have differences in invasive species. You may even have new species that maybe are seeded into sod that weren't there really in any old measurements. So you really want to have some new ongoing measurements that capture these changes that wouldn't be captured in historical measurements. Again, so this would be the lowest cost, most versatile. And then with the model too, that we can also make estimates each year, so that it provides for the possibility of having annual payment. So again, on the right side, you kind of see we're pulling together all the sorts of data. So we have information on soils, weather, different remote sense data, and then sort of what's happening on the farm. That sort of becomes sort of the key inputs. We have a monitoring network that provides support for a process model. And then from that process model, we quantify changes to soil organic carbon. And then from there, we have the soil organic carbon stock changes for grazing and forage lands. So based on, it could be a land parcel, could be a farm, could be a ranch, could be a project with many farms and ranches, but essentially it's a data intensive activity in terms of organizing all the data. But importantly, is making sure we have that high quality data to make sure the model is working well and giving us accurate estimates. So that essentially monitoring network, we've given a name, the Canadian Forage and Grassland Observation Network, or CAFCON. I guess we're happy if someone can come up with a better acronym. But again, what this is a national network, as we consider really as a national scale of implementation, a national network of monitoring sites of collecting high quality data on soil carbon, land use management data. And also that network can include things that are already done, done in the past. So it doesn't. So again, we're leveraging every possible resource that we have to keep it cost effective. And we link all that data with carbon models and yield prediction. So again, really, and also the models too can also produce estimated geographic and temporal baselines. So that's often, generally is the requirement for any offset protocol. So again, this is why our models really fit well with the needs for an offset protocol. And then a data sharing network with stakeholders with different data sharing agreements. So there's lots of intellectual property and other concerns, privacy concerns, and so forth, sharing data. So this, a big part of this actually then will be creating all those arrangements and agreements that will allow this data to be organized and accessible, and therefore support the ultimate goal is being able to have workable, low transaction cost offset, so that most of the resources or payment in a sense can go then to the land manager, as opposed to just supporting all the quantification. So what is CAFCON? Well, it just sort of indicates all the things it could be. So certainly experiments and demonstrations that are have been done or are being done are very logical, because of course they're particularly set up to show differences and to highlight improved practices. In some cases, it may be to just use the measurements that are already there, but in some cases may need to be adding on high quality measurements. We may be able to look at various across the fence sort of comparisons. Again, it takes time to get get good data, and we don't have a lot of time, or we'd like to have offsets sooner. So this is a way to, that's what's called trading space for time. And so in other words, saying these two were similar 5 years ago or 10 years ago, what's the difference now? Gives us an early indication of, or gives us a better indication, or not an indication, but an actual estimate, I guess, of how they would change. And again, particularly for modeling, this isn't so, can still be quite useful because we can model each one independently and also use it to validate. So there's something. And then we also, there may be particular management practices where, we may want to, with those that are interested and willing, is actually use their particular farm management, they have some unique practices and things that like to do, and we could actually incorporate some of those into the system. So you really start to you can build a national network very much in pieces. You don't have to try to do it all at once, and you can use all kinds of different resources and opportunities to build that network. Again, it becomes our observation network that supports the quantification. And so the roadmap, provides, of course, obviously this ability to understand how, so again, carbon is changing based on management and the state and management of the grazing and forage lands. But it's also a way for, many of the different stakeholders to get together to kind of find this way to get recognition and credit for these organic carbon increases that are happening to grazing and forage lands. So, we really have then a short-term strategy, which is to look really at starting all just to say what data is out there. Can we put together a repository for this data, compiling some of the data, really showing that this can work for existing, and then also to show how future monitoring sites could fit in. Then longer term is really then sort of pulling this repository, sort of making it more into this what we're calling Kafka, with all the agreements and with the ability to be maintained and accessible. So obviously, to make Kafka happen, there's going to have to be some funding, and certainly there are other data sharing, data compilation projects that we can build from. So it's called Canary, and I call Gauge Tree. I mean, there's some others that there could be other models or whatever, but so we're not starting from scratch. And then I guess there's just continuing the improvement, and I guess again, this Kafka is in a sense not the solution itself. It just supports the ability to have an offset. So ultimately, that part of it is also another exercise beyond Kafka, but of course it's kind of the rationale for Kafka. So we've just started the discussion with the various stakeholders and prepared a list of studies and data sets. We're putting together a team, and the Canadian Forest Grassland Association is front and center because they've agreed to kind of take on that secretariat role for this this whole initiative, including the data repository. And now we're really looking out for funding. So whether that's we're looking at some philanthropic funders, different public or private grants, private sector investments, voluntary contributions, or and also looking in terms, this data has value. Can we find ways to fund it, or at least provide support for this whole initiative through funding users. They can provide financial incentives when they're using it for ecosystem service model markets. And with that, then I guess that concludes the talk. So thank you.